Hello everybody. In this video we are going to see stack data structure implementation using linked list. So we are going to use the C language for doing this. First of all, what's the stack data structure? Stack data structure follows the property of first in last out, or I can say last in first out. So it can be implemented in two ways. One is array usage and one with a linked list usage. And there are three main operations of stacks, which is push, pop and peek. So let us see what's a stack. Stack is a one-way array like this here. I'm showing here. This is the empty array and it does not have any values. So if I put a value into the stack, and that operation is said to be push operation. Push operation will push an element into the stack. So if I want to push one more element into the stack, that goes just above the one which is present already. And the push, it can do only on the topmost. I cannot insert any element in between. And the removal operation in stack is said to be pop. It's called pop, P-O-P. Pop operation is removal of the topmost element in the stack. I cannot remove any element which is in between. So I can remove only the topmost element. That this operation is said to be pop operation, and I can put an element into the stack only over the topmost element. That operation is said to be push operation. This picture shows how the stack is using this array kind of structure for this usage. So for example, here 1, 2, 3, 4, 5. These are all the elements present in the stack, and 1 is the bottommost element and 5 is the topmost element. The topmost element is pointed by this a pointer called top. So if you want to push element 6 into the stack, so here I just have to put over this 5 and this 6 is present here. The top will be pointing to the topmost element. So if you want to pop element, that means if you want to remove the element, that's called pop. So it will remove only the topmost element. I cannot remove any element which is in between. So the pop operation removes the topmost element. So once it is removed, the top pointer is pointing to the previous one, that is penultimate one. That's a 5 is a new top. So if you are calling peek operation, peek will just return the value of the topmost element. It will not delete the topmost element. So the top pointer is still pointing to the topmost element, which is 6. Here it is changed to 5. So there's a push, peek and pop operations. This is looking like a array which is a contiguous memory. But if you go for a contiguous memory, we might not be able to store huge amount of data. Since we are storing these kind of things in a RAM structure, the RAM might not provide huge amount of space which is contiguous in nature, but it can provide a space which is scattered. So that is why we are going to implement this stack using linked list. So here, this is the array implementation, and you see top is here. So the equivalent to this one in a linked list way is this way. So here, the top will be the head in the single linked list, and the bottom will be the last node here, the 2. So 1, 7, 5, 2. The top element is element 1, the bottommost element is 2. So the topmost element is equivalent to head node here, and the last node, the 2, which is the bottommost in the stack. So if I call pop operation, I have to remove the head. That means we are removing the topmost. We have to remove the head node, and this second node will become the head node. If I call push operation, then new node will be made as a head node, and the new head node will be connected to the previous head node. So this way we can do this. And I can show an example for this. So this is one to replace. So we are replacing head with the top pointer points to the first node, and this is a singly linked list way structure. The last node is a bottommost element. So here in this example, say for example we have 3 nodes. Okay, each node having address here. 5000 is the address of the bottommost node, 4900 the above one. The topmost node's address is 4800. So that is why the top pointer pointing to 4800, which is the address of this node. So this node is storing 4900. That means the link is established. This node is storing 5000 address, which is the address of the bottommost. So this link is also established. So this is the stack, and the top is equal to head here. If I want to insert an element, or you can say push an element into the stack, because stack has push operation. Push means I have to put a new node here, and this top will point to this new node. This newly created node will point to this node. Okay, say for example, this is the new node created, which is having 4700 address, and it is storing 4800, this one's address. So the link is established. Now the top is pointing to 4700. This is push operation. Pop operation means I can just remove only the topmost element. So if I perform, say for example, 3 pops, 1, 2, 3, all 3 are gone, so I'll be having this one. So this is a 5000 is a top now. So push 1 will remove this one, then top will be having 4800. Sorry, pop will remove this one, top will be having 4800. If I do another pop, it will remove this also, and it will be storing 4900 here. If I do one more pop, then it will remove this also, it will store 5000 here. So top will be pointed to the 5000 as in here. So if I do 3 pops, I'll be here. We will implement this using C language. So in the earlier video, we have seen linked list creation using C language. So there we have elaborately discussed about how a node is created, how the links are formed, so that if you want to know much about creation in detail, you can see that video, which is singly linked list implementation using C. Now this here also I will to explain in detail, but if you want a more explanation in detail with respect to creation, you can see that too. Okay, so first we have to create a node. Okay, what's the node structure? We have to create a struct node, and like this. So it is having a data. You use an integer. So here you can see this one. Say this node is having a data and it's having an address. Address points to the next node. So we can just say int struct node star. You can just say next. Okay, so next will point to the next node. So here, once this is declared, we just create a top pointer. Okay, initially it's equal to null. We'll just use our main here, and it's going to return an integer, which is here. So let us compile this. So here we will just include h. Okay, so it's compiled. Compilation is over. So after this, we're gonna write a function called push. Push will get a value, so you can just say int value, or you can just say int value. It's going to return the void, and first we'll write this push function. So what push will do? So if you call push into the stack, value 10 into the stack, this is the one we are calling. So what we have to do, we have to first create a node. So if I want to push, I have to first, initially it is empty. Okay, top is initially null. Okay, it's empty. So in this case, it's empty means top is pointing to null. So we have to create a node first of all. Once push is called, we have to create a node. The size of struct node we are giving. So once we give this one, we have to typecast it to struct node star. And this is the malloc usage. Malloc is defined in std_lib. So we'll have to use this std_lib also declared. Now initially we create say new node equal to like this. So this declaration also we will do here. Initially it's now. Okay. So new node is created. New node's data. So what's the thing we are passing? So new nodes data equal to value. So there's a data member. The data member we put, that is value. But it has one more member, that's next. So new underscore yan. The one more member next is equal to null. Okay, so what we have done, imagine this is not there. So this is the first node we are creating. It is pointing to null, and we are storing number 11 here. Okay, so for example, we are just passing 11 as they do. So 11 is stored here, and it is pointing to null. So what we have to do here, this is the top pointer. It's like equivalent to head, I told you. right? So this top is going to point to the first node. So here, when we are doing this one, once we create a new node, the new node will be the top node. So top, I can just use top node, top underscore n. That's also top node. So top underscore n is equal to new underscore n. So new node is now this done. So 5000 is stored in here. Okay, I don't know what's the value here. So new node is created. So we are storing 11. 11 is because I'm passing 11. 11 is stored here, and the next is stored with null value. And now top node is pointing top pointer. This is a pointer. This pointer is now storing the value of this address returned by this creation. That means it is storing. It's here 5000. It's equivalent to that storage has happened. Now it's fully done. Now this is a push. Once you push it what we have to do? It's happening as. But imagine if I call one more push, what will happen? One more pushes. So here the 22. Okay, I'm calling 22. So push 22. If I call, what should we do? We are coming here. 22 new node is created. Okay, above this one. So for example, above this new node is created. So it's going to have 22 is put up. Okay, it's going to have 22 put up, and it's initially having null. Let it be. Okay, initially having null, and then there is a top. Okay, so in this case, earlier top was null. Okay, now it is not null because it is having one node. See, when I'm creating first node, top is null. So that is why we are just directly putting it. But now it is not null. If it is not null, means the new node should be connected to the already present node that is present at the top of the stack, because it is going to top only. It's going to point only the top of the stack. So the new node should point to top one. Okay. So, but if it is null, I can directly put it. So what you have to do, we just have to make one condition. Okay. So if top is if top is null, or I can just put top. If top node is equal to null, what we are doing, we just make it a new node. Okay. Else what we have to do, we just say new node which is created, new nodes next will be equal to top nodes. Okay, so this will happen. So new nodes next is initially null. Okay, so in this case I can just put top is like this, and new nodes next is null. So this is the first time creation. So this is for first node creation. Bottommost you can say bottommost node creation. That means first. I can just say first push. So when the first push happened, the bottommost node is created. That means at that time top is null. So that means top is directly pointing to this new node created, that is 5000 here, and new nodes next is going to be null. That is new nodes next is null. But if it is not that case, if I'm creating second node, that means I'm calling push 22. I'm calling 22 here, push 22, value 22 is put up. So I created a new node. New node is this one more new node is created. It is having 22. The new node should point to the already existing top node. That means what is already existing top node? Because it is not equal to null. Okay, that means it is going to else part. Okay, so if it goes to else part, then we just say new nodes next is top node, and top node is equal to new node. Okay, so this will happen. Say, since you can say this two are this will always happen, top will be pointing to new node. This will always happen. Okay, so I can just take it out of, I can put it here. Okay, so only this one. So if top is initially null, what's the meaning? That means there is nothing in the stack. So I just create new nodes next is null. But if top is already present, that means it is not equal to null. We are just claiming new nodes next is equal to top node. Okay. After that, in both cases, the newly created node will be the new top node. Okay. So the created node is made as a top node once we are done. Okay. So this will give a push. thing, right? So if I want to print and see, okay, we'll just print the whole this is just for the verification. Okay, so if you want to print, say print if you want to print stack, okay, you just say temp equal to top, okay, while, and I can just say temp printf percentage %d. You can say temp of data, temp equal to temp of next. So this will make it. So here we will just declare star temp equal to null, and you have to understand this is also a pointer. I made a mistake here. So there's a pointer, all of structure pointers, right? Structure pointers. So temp is stop. So this will make get things printed. So let us see what we have done to now. So first push 11. So this will first node time. It is creating a node. It stores the value 11, and the top is initially null. See, because it is a global variable, the global variable initially set up to null. So it is null. That means it is true. It enters new nodes of next is equal to null. Okay, see here the bottom nodes next is made as null. So if I create one more node, okay, top is equal to new node, so top is pointing to new nodes. That's address is 5000. That is stored here. So if I create one more node, so it will come again here. 22 store new node is created, 22 is the data, and we have to link this one. So top is not null, it is having value. So in this case we'll go here, new nodes next is top node. So we've made a link. Okay, so this link is established. This storage of 5000 is this one. So top is pointing to 5000, new node is here, new nodes next is now storing the 5000. That means this link is established. After establishing the link, what we have to do, we have to make the top pointing to this one, that is 4900. So 4900, so that is why we are doing this one outside. So only one line belongs to if and else. So this is a common one. Okay, so now once we have done that, if you want to see printed, that means if I just put 11 and 22, which is going into the stack first, 11 went into first, so 22 went after the 11. So that means when I top of the stack is 22, so it has to print 22, then it will print 11. Let's try. We just made some errors here. This is top underscore n. Semicolons in here. Yeah. Okay. Okay. So it has to print 2211. To call this, I did not call it. Let me call. Okay. So it prints 22 and 11. So that's a push operation is clear. So I can give some space to see what's present here. So first it is 22, then 11. Okay, the topmost element is printed, then next one. So this way we are just seeing, but if you are implementing pop, what to do with the pop? Let us see. Right, so push is done. So what pop will do? Pop will return element. Okay, so pop function will return the topmost element to us. Okay, so how to do this? We'll just see. So what is the topmost element here? Say for example, this if I do pop here, this 44 should be returned, and this node should be deleted, and the top should point to this 33 like this. So it should go to 33. Okay, so it should be removed, and it should return this 44 to me, and top should point to 33. Okay, so this is the way it should work. So if I call pop, say for example, we'll just do some more pushes. Okay, so we just do 33, 44, 55. So if I do this fix, let to compare and trim. So 55, 44, so top to bottom it is printing, right? So what we have pushed first one, 11, it is printed lastly. Okay, so that is fine as of now. So if you are going for a pop, one pop, if I do, what it has to return? It has to return 55, because that was the one which is pushed lastly, last in first out. That's what pop is. So if I call pop, what it should do? The topmost element value. So if I just say int val equal to, I can just say top underscore n. That's one's data. I just store the data in the val. So we're going to return val only. Okay, finally we're going to return val. So before returning this, what we have to do? First we made this one. So we have just stored this value in a val. Okay, this is a temporary variable, local variable. We are going to return that value. So before returning, what we have to do? We have to make this top point to the next one, and we have to delete this one, right? So these are the two things we have to do. So for this one, we just store it in a temp. So temp equal to top underscore n. So temp is a global variable which is a pointer for struct data node. Okay, so the node is pointed by temp. The top node is pointed by temp. Now I'm going to remove this 44. Now temp is also pointing to this topmost node. This top is also pointing to topmost node. Temp is also pointing to topmost node. So now I'm going to move this top to point to this node. So that temp is pointing to this node, and the top will be pointing to the one previous to this one. Okay, that's what we are going to do. So now top, we just have to make the top is equal to top of n is equal to top of n of next. So what is top's next? Now as of now, top is pointing to. So top equal to top of next means 4800. So it will be pointing here. So top will be pointing to this one. That means it is ready to be destroyed. Now temp is storing this value, right? Now temp is storing this one. So we can just call free. Okay, we can just free this one. So I can just free temp, because temp is still pointing to the one which is for deletion. Okay, so first we made the top stored in temp. Now we are moving the top. Now the top is pointing to the penalty mate one. Okay, now we are after doing that, we are removing this one. Finally we are just returning the value back. Okay, so this will do the job. So once after doing this one, if I see the print stack, okay, what will happen? So print, it will be just remove this one. So 44 will be the new one. So 44, 33, 22, 11. So it will happen this way. So here I'll remove this print. Okay, this is coming after this question. So after this pop, it is just giving me 44. 55 is removed. Okay, 55 is removed. So this is the element contents. If you want to see, it has to return. It is returning a value. It's return. So if I want to know what it is deleting, so I can just put this one, pop is put up here. Okay, so whatever the value, the return will be printed here. Okay, so after the deletion we are printing the stack, so I can just introduce backslash n. Okay, popped value. What's a popped value? Okay, sorry. So pop value is 55. Okay, so I can enable this too if you want, and then print stack and backslash and I'll put here too. So first the stack is containing the elements. So 11 is pushed first of all, then over the 11 22, then over the 22 33, then over that 44, then over that 55. So now top of the stack is 55. So when you print the stack top to bottom, 55 to bottom 11, when I call pop, okay, when I call pop here, we are calling pop, the pop returns the removed value, which is the topmost value 55, that is removed, and that is 55 is given. After the removal we just have to print the stack. We see it is having 44 33 22 and 11. Okay, now what we have to take care here, so if I call many pops, okay, so now there are 4 elements, 55 is removed, then 44 if I remove, then I can remove 33, then I can remove 22, then I can remove 11. Okay, but if I remove the last element, okay, then top should be made equal to null. So you see this one, if I remove this 44, top will be pointing to 4800. If I pop this one, top will be pointing to 4900. If I remove this one, top will be pointing to 5000. If I remove this one, top will be pointing to obviously null. Okay, so if top is pointing to null, that means it is no, because what we are doing here, you see, when you are removing, what we are doing, top and top equal to top of next. When top is pointing here, which is top's next is null, so we made top and null. So when top and null meaning nothing is there in the linked list, okay, it is null, so as if it's fresh, 0 size linked list, no nodes. So after that you cannot allow pop. Okay, so pop has a limitation, so you can do pop on the linked list which is having values. So first of all, so if you are doing initially checking, okay, if top underscore n, okay, if we just put a not of, so if it is null, okay, not of means not null, it will become true. So in this case what we have to do, printf stack does not have any value. So it's empty stack, you can just say empty stack. Okay, it just returns the empty stack, or I can just say -1 or something like that. Okay, because it returns a value. So if you want to return, I can return print empty stack, then I can return some number. Okay, that means invalid. I can keep something as a invalid. So printf return -1, that's invalid. Okay, meaning it's invalid. So here when we call pop again and again, say for example I call pop, so I'll just say I'll disable this print. One more. So how many push we have done? 1 2 3 4 5 push, and we have done 5 pops. That means it's empty now. If I do one more pop, that means it should put the value. Okay, so it should say the value. So first of all, we're running this. So this is the stack: 55, 44, 33, 22, 11. 11 is the bottommost, top is 55. So first pop, it is 55, then 44, then 33, then 22, then 11. After that 11 is popped out, then we say empty stack. pop dot value is -1. It's invalid. It's just like a flag you can keep. If you have a data -1, you have to just have a true or false or something like that. So that can be taken care, not a big thing. So this you have to take care. So push does not have any limitation in stack, because as far as the memory is there, you can just go on pushing element into the stack because it's a scattered memory. That's the advantage. But in case of pop, you just cannot just pop a empty stack. Okay, that has to be taken care. Okay. So what we have done now, so we have returned first what we have done. We have included the necessary header files. Structure of a stack node is declared, node and next, and we have a top node pointing to null, new node pointing to null, temp null, and we are writing a function called push, which is an operation in the stack, which it gets the integer value and we are storing it as a data. So once we create the new node, we store the data, then we're just making the connections appropriately and we are updating the top pointer. Okay, so in the pop function, if the top is null, we are saying it's empty. If it is null, means it is not of null, means it will become positive. That means as a true, boolean true. We'll enter, it will say empty stack. If it is top is not null, means it is good for popping out. So if I pop out, it will be just storing the topmost element and it updates the top pointers appropriately. It frees, okay, it deletes that one. It's our duty to delete because it is dynamically allocated memory. So free and malloc are defined in string std_lib library. Okay, then we have written a function, okay, which is print stack. Will just print the whole stack. Okay, the peak is the one which will just print the topmost element. Right? So that's not a big thing. So if you want to write a peak function also, you can do, not a big one. So peak. Int peak. So if I call peak, it just peak returns the topmost element. So if top node, so if it is not null, so if it is null, that means it just says empty. Okay, empty. Else I can just say, or I can just say if it is not empty, I can just put it here. In the else part, I can empty. If it is not null, that means something can be seen. So it is just printf %d. Okay, top underscore ends data. It's not going to remove anything. Nothing it will do. Right? It's not like pop. So it's just prints. So it is a very simple thing to do. Okay. So after this, if you call peak, it just returns. I can just put it in this way. The top value, topmost element, top value to just print. Okay, I think pop to is I think the double P for this pop value. So that's peak one. Okay, so that's a peak function again, right? Wait a minute. because of this printf, I'm getting all these. I'm used to Python programming. You just have to print f we have to give. In Python, you just print. That's why. Okay. So I hope you got something from this. So I'll compile and run and show it. Again, still we're having. Okay. So this is a peak value. Okay, peak value is that's the top value is coming, right? So peak, when I call peak, printf top data. So if it is not empty, so it has to return. So it will make it wide, and that's why it's coming. Right. Okay. So it's returning a value. Okay, so and what you can return. No problem. We just return here itself. Just return the value here. Okay. Okay. So once we do this, we have to return the top data we are returning. Okay. So you see the compilation, the top value is 55. Okay, so we are printing fully. Top value is 55. Once you are done the pushing, the peak value, it just prints the top value is 55, and it's printing the whole stack, then popping one by one, the finally it is -1, right? So this way you can implement stack using linked lists. Okay. So thanks for listening. I hope you gained something from this. Thank you.